Let's do a problem from your lab assignment, section 11.10. They want us to find the sum of this series. This series. We want to make sure that we can identify this series as something. I see a negative 1 to the n alternating. I see an n factorial in the denominator and x to the n in the numerator, x to the 7n actually. But we can break this up probably into something to the nth power. So here is what they're wanting us to go to, is that e to the x is equal to x to the n divided by n factorial. That's one of our popular series that we should know. And we somehow need to be able to rewrite this big old mess. The negative 1 to the n, 3 to the n, x to the 7n, all divided by n factorial. They want to rewrite that as something to the nth power divided by n factorial. So the n factorial seems pretty obvious. It goes down there. We have a negative 1, and then we'll take the power of n out. There's a 3 to the n. Let's put this in parentheses. And then there's an x to the 7th to the nth power. So maybe we'll just say this is x to the 7th. You can certainly multiply these two. Negative 3 x to the 7th. Let's just leave it like that. So we have negative 3 x to the 7th to the nth power. So according to our formula, e to the x, if we just replace x with negative 3x to the 7th, then we have this exact same series. So therefore this thing must equal to e raised to negative 3x to the 7th power. So that is the sum. If we had specific values for x, we can actually just put that in and get the values. But here, more generally, we've found a function that represents this series. And the series can be represented as e to the negative 3 times x to the 7th. Okay, I hope that helps.